Hey guys, this is just a quick video about problem number 3 on worksheet 1. I was asked a question about it today and this integral came up. Now this is not the original integral from the start of problem number 3, but if you do integration by parts, you're going to end up with this integral. So I want to talk about this real quick so you have an idea about where to go from here. The first thing I tried was substitution, and substitution just didn't work on this. But a technique that we're going to be using more in section 7.4, the next section, is going to use this same kind of thing I'm about to do right here. So I'm trying to take the integral of x squared divided by x plus 1. Now this is a rational function. X squared and x plus 1 are polynomials. So I can actually divide x squared by x plus 1. And if you have taken college algebra, if you remember from your college algebra days, there was something called long division of polynomials. You might have done synthetic division. Synthetic division will work for this, provided you do it properly. So on the next slide, I've got the long division here laid out. So I've got this 0x plus 0. That's just to fill in the extra spaces that I'm going to need. Now I'm going to go ahead and just fill in the long division, and if you're familiar with this technique, then work through what I have here. If you're not familiar with long division of polynomials, try doing it with synthetic division, or go on to a website like Khan Academy and just search for long division of polynomials, and they'll walk through some examples of how to go about doing this. But if I do this division right here, I'm going to end up with something that looks like this. So the quotient is right here that I'm circling in blue. This is my quotient right here, and now I'm circling the remainder as well. So this plus 1 over x plus 1, this comes from the very bottom. So I have this plus 1 over this x plus 1. So this is what I get when I divide x squared by x plus 1. That means that this expression, this rational function, is equivalent to what I have here in blue, which means I can replace them and end up having to take this integral instead. Now these first two terms, the x and the minus 1, that's just a polynomial. We can integrate that pretty easily. And for 1 over x plus 1, the integral is natural log of the absolute value of x plus 1, because it's of the form y prime over y. So this right here is part of what you will need for problem number 3 on the first worksheet. So if you just want to use the work that I have here and put it into what you've got, that's fine. But it's important that you're able to show me how you got to this step right here. If you can show me, now remember, this integral is just part of the answer. The rest of it will come from the integration by parts. But solving this part of the solution, this is what you will substitute it with. And you'll see more of this long division of polynomials when we get into section 7.4 and we start talking about partial fraction decomposition. So if you had problems with problem number 3 on this worksheet, see if this doesn't help you, and that should be it. Okay.